Hey, this is Joe at Gray Bench Electronics. Today we're doing a repair on an Effectrode tube vibe. All right, so this is the Effectrode tube vibe. It is a Uni-Vibe pedal that uses tubes for the phase cancellation stages. The Uni-Vibe effect is sort of a type of a phaser, but instead of using like the original MXR phaser uses a FET as like a variable resistor. The tube vibe uses photocoupling, so it has a little lamp in there. It's got some photoresistors, and that affects a series of tube gain stages that will cause a notch effect in the output signal. And then you can vary, obviously, the output volume here. We have the speed, so that'll be how fast the notch moves back and forth across frequencies. And then the intensity, which is, it's either going to be the depth or the Q, the width of the notch. So, but this one's not working. So I guess first thing we should do actually is plug it in and see what happens. All right, so we're just going to do a little test of how the pedals work right now, just to know where we're starting. I picked this up off Reverb, and the original seller said that when you plug it in, it just crackles and doesn't pass any signal. I've got a little test amp here, one of those little Yamaha test amps that I use just for quick sound checks. I got my guitar hooked up. I've also got a Variac here with a digital multimeter attached. And the pedal did come with the original, well, I don't know if it's original, but it came with a power supply. It is too light, so it's not linear. It's going to be a switch mode power supply. So let's plug this in, see what happens. This Variac lets me see what my output AC is, which we're going to set to 120 volts. And it also lets me see current consumption. And I can see, according to the multimeter on this, the power supply itself draws 60 milliamps. All right, so let's plug it in and see what happens. All right, we've got some current draw coming through. Currently drawing about 1/4 of an amp. LED works. I do see the filaments lit up, so now 1/4 of an amp seems too low, but maybe not. Let's turn on the test speaker here. Okay, go ahead and bypass. A little bit of crackling. A lot of crackling now. I don't know if you can see that there, but the LED is flickering. So we got some crackling. It's vibing a little bit, but it's very crackly. Could just be a bad tube. But the best part is we can see that light is moving and responding to controls, which is good. All right, we'll turn this off. That's a good thing because as far as I know, the actual LFO circuit in this is created digitally. And so if there's any problems with that, that's going to be a lot harder to fix than just something in the analog path. So definitely have some problems. Could be a bad tube, but hopefully it appears to be something more in the analog side rather than the digital side, which is good for me. So to go over what we know so far, the LFO appears to be working, which is good because that's digital. The tube heaters are lighting up. We do hear there is an effect coming through, but there's a lot of crackling and ugly sound in there. And the effect is very weak and very low, and just the output's low in general. So there's the inside of the pedal. Now, right off the bat, I noticed something that could be important. That right there. A little discoloration from heat. Could be nothing. Could be totally normal, or it could be something. It's definitely something. It could be an okay something or a not okay something. Wait. How is this going to come out? Oh, what? Oh, wow. Okay. So, little note on the bottom of there. It says, desolder pots to disassemble. Okay. Not sure how I feel about that. I guess on the one hand, that will keep people from messing around in here who shouldn't be. And presumably anyone who knows enough to be messing around in here on a tube circuit would also have the ability to desolder pots. But on the other hand, I kind of wish I could just take the pedal apart without having to desolder the pots. We should also mention, actually, we should be safe here. As far as I know, this does have a high voltage power supply. And while there's probably not enough juice in here to actually seriously hurt me, I'm not really interested in getting shocked either. So let's just confirm that the pedal does have some way to quickly the pedal has some way to quickly discharge itself for voltage. The pins of the tubes that would be connected to the high voltage supply. Yeah, it looks like there's probably some kind of bleeding resistor in there just to drain off the filter caps. Okay, cool. All right, so we're gonna try just swapping the tubes. This is an old Westinghouse 1287. I know these tubes are responsible for creating the phase cancellation, but I don't know which specific tubes are doing what, so we're just gonna swap them one at a time and see if it matters. Still crackly. About the same. Got V1, the original tube, back in there. Let's swap V2 now. Okay, and let's fire her up. Still crackly. It's just the same. Oh, we got more though, I think. Sounds weird though. Doesn't sound right. Sounds more like a tremolo than an actual phaser. But that is an improvement. All right, I'm gonna leave that 1287 in there. I'm gonna swap the 12AU7 now. All right, let's pop that in there. Still crackly. So, okay. So, it appears that swapping the tubes did not fix the problem. It improved the output, but there's still a lot of crackling going on. Who needs coffee in the morning when you can just huff contact cleaner? That was a joke. Don't come for me, YouTube. I'm just going to each tube socket, inserting and pulling out the tubes from each socket just to kind of scrape any oxidation that may have formed in there off. All right, let's see if that did anything. Nope. It's vibing though. Still a lot of crackles though. It's mostly there. It's definitely an improvement already over where we started, but there's still that crackling going on. All right, I've got a different 12 AT7 here. No crackle? Come on now. It's still crackling. I'm fairly confident it's not strictly a tube problem, but we're going to have to hunt down that crackling, and it probably means we're going to have to take the tube apart, or the pedal apart. So let's crack her back open and see about pulling those pots out. Just want to have a peek inside and see. I know we saw that hot spot on the underside of the PCB, and I'm wondering if we can see in and see what that was. Oh yeah. Okay. So that's there. Yeah, so as I look in here, oh, okay. I see two things actually that are concerning. I see a resistor that looks pretty dark, and I actually see a little bit of ugliness between the trace for that resistor and what I'm guessing is the ground plane next to it, as if it like the trace is arced together, which is not good. Okay, yeah, we're definitely going to crack this open now. All right, so like we determined before, we do have to remove the potentiometers to get the actual board out of the enclosure here. So I'm just going to use a combination of solder wick and a desoldering pump or a solder sucker to do that. All right, so here's our PCB removed from the enclosure. There's that hot spot we were talking about. Unfortunately, it was lead-free solder, which is always harder to work with, so desoldering the potentiometers didn't go as smoothly as I would like. Did end up losing this pad here for the intensity pot, but we have some copper here we can connect to, and also the pad on this side is fine. So here is the resistor in question, R22 here. You can see it's kind of blackened and ugly. So definitely want to replace that resistor. But also up here on the trace, you can see there's a little blackened spot where it looks like the trace here, which is going to the plate of the tube, so it's going to have high voltage on it, arced over to this larger copper plane here, I'm presuming is ground. So that's concerning, because if it can arc there, and if it's just a matter of the trace distance between ground, then it could happen really for any of these traces where it's high voltage next to ground. But we're going to proceed with the repair R22 is getting replaced here. Got to figure out what value that was. And we're going to scrape out this spot, just make sure there's no carbon in there and nothing conductive touching between the two. I was just touching it with the piece here, and it was barely connected. It actually roasted the pad right off the PCB on the backside there. So there's the little resistor with the pad still connected. All right, so I got that cleaned up as well as I can here. I think what I'm going to try and do, I don't have any of these, funky little surface mount resistors. So what I'm going to try and do is put a through hole resistor in there and use the via that is part of the PCB there as the through hole, and then come in here, clean off some of that solder mask and just solder it on the back there, wherever you come in. Yeah, I'll just clean off some of that solder mask and then solder it there. And then to make it look neat, I'm just going to fold it over and tack it right onto the side of the socket there. All right, so got the pesky little surface mount burnt up resistor removed. I believe it's a 22K. At least that's what I put in new. It's a through hole. Put in a new through hole resistor. Where are we? New through hole resistor in there. So let's partially reassemble and see what happens. Got a little test hooked up here. I want to test this out of the enclosure because I have to put the pots back in to actually get it back in the enclosure. So I just have some pots wired up with short wires here. It's still going to buzz a little bit extra because it, there's no shielding from the enclosure. Okay, power on. Vibing. Cool. All right, so I feel like that plate resistor was the culprit. I'm feeling pretty good about this so far. I'm gonna clean up the board a little bit more, and then we'll put it back together and give it a play. Yes, so here's that burned pad. This is the wiper for the intensity pot. It connects here to this trace, which then goes up into the board. So we're just going to clean off a little bit of the solder mask. I've actually already done it. There's a little bit of flux here. That's just this darker area. It's not burned. But we clean up a little bit of solder mask on this trace and then connect a little bit of lead to the wiper lead from the potentiometer. And we can do that once we're already assembled, actually. Okay, so here we are back with the tube vibe. Replaced plate resistor, cleaned up board, all assembled back together. Let's give this thing a listen. But no more crackle, that's the important part. Let's listen to the chorus mode. Back to vibe mode. So this is the smooth, I believe. All right, so that wraps up the repair of this Effectrode tube vibe. If you have any questions, feel free to leave them in the comments. I'll do my best to answer. If you enjoyed the video, I'd appreciate hitting the like button, and feel free to subscribe and hit the notification bell if you want to see more videos like this. I am Joe from Gray Bench Electronics. Thank you for watching.